Yes, I think we stopped at a place where we were trying to drop all the irrelevant columns, and we said there is two ways you can do that. Can someone remind us? Rodovan, can you help us with that? Can you remind us? Yesterday we said that there is two ways you can drop the irrelevant columns.
You
You
can
can
use
use
the
the
df.drop,
df.drop. Yes.
and
And
then
then
you
you
can
can
also
also
use
use the
you
you
can
can
also
also
print
print
the only the columns
columns
which you
which you
want
want
and
and
exclude
exclude
the
the
others.
others. Oh, yeah, yeah, yeah. Yes. Those are the two. Those are the two ways in which you can drop the irrelevant columns, and we just I think we used the second one where we were trying to just indicate the columns that we want to use, and assigning that one into a variable that is called now the new df here. So df is equals to the sofifa underscore id, the player url, you have the short name, long name for the player, and the player position. So, and even you are able to print the head of that data. So I think that's all with dropping the null values. And I think I would also like to, I mean, dropping the irrelevant columns. I think also yesterday we checked. Did we check the renaming of? Yeah, yeah, yeah. I think we checked also how we do rename the columns. So today I would like us to check something also that is in this step, that is called the replacing of null values. There is a number of ways you can replace null values. There is always there is a number of ways we can do this. So let me just, I think you can just type something here before this. You can have something like replacing the null values. So if you were to check our data set here, let's have these df dot head. Let's bring the first 20 columns. Let's check if we have null values in these columns. And you can see in this column where we have, let me show you. This is now the nation logo URL. You can see that there are places where we have null values, right? I think I can just use I just want to use the whole data set. So let me just comment out these. Let me just comment out that so that we can have all the data set displayed. Oops, why is this taking so much time? Yeah, I think it has displayed that. So let us check on these. Let us just check the null values where we have null values. It could be better if we can find a numerical column where we have null values. Okay, it's okay. We can still use the national logo. Uh, so we can replace this one with maybe with a message rather than having the NAN. And what could be the reasons why we didn't record the national logo URL in this data set? So you can always maybe replace that with a maybe with a message. Let's say maybe where we have let's say the non value in this column, we put some maybe a message. We can put a message. That message maybe can be the reason as to why you don't have what you don't have the reason why we didn't correct the nation logo URL. So we do that now using now the replace method. So let's say maybe you are replacing null values with maybe with a message like um, we can say that the message has no logo, or maybe yeah, we can use that messages no logo. So let's see how we can replace that using the replace method. Let's have we have the nation underscore logo URL. I think I should indicate that you're using the replace method. This is using replace method. Good. Uh, it's just a simple syntax. How we do that? You just have to indicate that is our df. Then we specify that column, and the column is, let me check that again. That is the nation logo URL. This is nation logo. Oops, should be in this nation underscore logo. It's nation flag, no nation underscore logo, yeah, and then URL. We have that, and then this one we can equate this one to now our method here. So it's df, and then we just have to indicate that it is in this column that we want to change, and then we can use now the method. So we just have to use the dot operator, and then we indicate that we want to use this method. That is a replace function, and we are replacing this with let's see this. We're just going to open a dictionary here, and we say we want to replace where we have this is NaN, that is the null value, uh, with the value that you want to replace with. In this case, we can say that no data. Let's just use no data corrected. Or we can just say no. Uh, which is the best message that you can use here? Any suggestion for a message that you can use here? Any message? Any suggestion? You can just unmute and tell us the suggestion you think that is right for us to use.
Logo preview unavailable.
Okay, so logo preview unavailable. Yeah, let's use that. That is logo preview and available. That another one, or maybe we can have. Let's use the unavailable, right? I think unavailable is just. I think you can just use the unavailable, just one word for that, right? So after this now, when we run these, let's just run these once more. Let's see if you are able to replace the NAN with unavailable. I think it is taking so much time to run these. That's why I don't like using, by the way, using the actual data sets because of these delays. But hopefully, let's good. So let's check if you're able to replace that. Uh, yes, a question, Carl?
That is accidental.
Okay. It's okay. I think this one is supposed to be. I think you're using the wrong brace. We're using the long. Okay, let me see this. No. I think it should be Carl braces. Sorry?
It was not
Sorry? Who is talking?
it has not worked.
It has not worked. That is what I'm checking. What could be the problem here? I think I can just try to print this. Let's rerun that and have the I think you can just set this one to the new data frame. New underscore df is equals to that. Then we can have new df dot head. Let's have the first 20. Let's see why it is not working. The NAN. Oops, why is this not working? Let me see this. This one should work for us. We just try to check the options that we have here. That is Alt Tab. Okay, let me just try to do something here. This should be working. Okay. This is replace nation logo URL. Let's see this. Okay, let's counter check this. This is from pad does what? Let's see. The replace function. Let's see what we are missing in that. I would like to check from the documentation, Python documentation. Let's check from this and see what you are missing. This should be working. Okay, just a minute to figure out these. And if you have any suggestion, maybe you can help us to, as I try to figure out what could be the issue with the syntax here. Yes, Lord.
For this one, I haven't figured it out the replace function, but I have tried to use the fill now and it has worked. But for this one, it has not worked for me, so I don't know why.
You know the fill now will work for all. Uh, but I thought we should be specific on this one. That is why I was trying to use the replace function here. But this should work. Let me just check the. Okay, let's try with a different column here. Let me just try to use the old data. Yeah, but should be working. Let me just check this. Should make Google your friend. Let's see this. I think we should be able to check this from here. Let's search the replace function. Let's see this. I think we should be able to check this one from. I think this is how now we use the documentation they have provided. Uh, we have the field series string replace as. Within the replace. Okay. I can see we have the right syntax, because you can see df.replace. We have the replacing these with these. Yeah. Let's be more specific. Don't know why they are not giving us the. A minute, just a minute. I check this. The service. Let's use the next tool here. I think this one should be able to help us. We don't have to struggle, and we have the chat GPT here. Let's see this. Yes, I think we were missing something here. Yeah, that is the np.none. That is the np from in fact, I've just realized something here that the NA, this one NA is a data type. It's a data type in NumPy, right? So I think we should use the NA in NumPy. That is the none. That what? Let's check that again. Yeah. This is where you are wrong. That is the np dot none. Should work for us now. np dot none. Uh, so let us just run these. This is new df dot this should work now. Again, it is taking so much time, so let us be patient with these. Yeah, and I think it has just worked. Oh wow. Yeah, I think that is the problem we had. So this one none, the null values none. I think we must use the pandas to recognize the null values. But if you want to use the fillna, I think that one is quite straight. That one is just quite straight. But if you want now to use you want to use the replace function here. You can always, if you want to replace the null values, then you must use the np. That is the NumPy library, which we had imported earlier as np. That is importing NumPy as np, and then it has a way of recognizing null values in a column. So, any question? I think that is it with the replacing. I think this one is quite interesting. So I think that is something that you have learned also. Yeah. So I think that is it. You can also do replace multiple columns. Let's say maybe we wanted to. Let's check this. Let me just try to print out this data set again. Df dot. Let's have df dot head. Let's run this. And I think it is just taking much time. So I think you can just subset these, have a subset of this data set so that we can save on time. So let's use this. I think I should run this first. I don't know whether it's from my side, but this one is now becoming too slow. It is taking so much time to execute. Uh, Good. Let's run this now. Yeah, I think you can focus on using these five columns. So I was saying that you can also replace multiple columns. And how we do that, let's say maybe we want to replace the null values in in the in this column in the nation underscore logo underscore URL column, and then let's say maybe we want to replace also the maybe we can also maybe try to replace where we have this long name as long name where we have that is Lionel Adre Messi, and then this name here, maybe with something else. So you just have this is like going to pass a list of the values that you want to change, separating them with commas. So we can have, let's say, uh, we can have these. Let me show you. I think you can just with this one you are just focusing on. That is on the same column, but different, maybe replacing different values. So also let's see these. That is df first. Let's have 5. Oops, don't know why we have an error again. This is the national logo URL. Let me see this. I don't know what is the problem here. Might simply because we enabled these. It seems this is taking so much time. So in case you want to change different values using the replace function, as wait for it to run, you just have like to pass the series of data that the series of values that you want to change. Let's say maybe also in this column, maybe you want to change maybe a certain logo. So you can just copy the logo. I don't know if this has finished to execute. I think it has executed. So let's see this. You can copy now that logo. Let's say maybe you have one logo here. Maybe you can just call it logo A, and you want this to change it to something to do with logo B. So meaning that you can change multiple values in a certain column, and this normally happens in cases where uh, you have a column that you want to have customized values for easier for customized values, so that it is easier to work with, because sometimes you get a data set with values that you are not able to uh, that are not clear. So you must customize those values. Maybe just in cases where you have maybe let's say maybe a column having values of one maybe digits, having maybe one to three, assuming that 1 to 3 is there are some categories. So instead of maybe using those 1, 2, 3 categories, you can replace those 1, 2, 3 categories with their names. That is in a certain column, and that is why we are using these now replace. Let me just demonstrate that. Um, let's say maybe I think I can just do away with this. Let's say maybe we have category one. Uh, um, let me just put let me just put a colon there. So let's say category one is prayers from NEPL, but in your data set, it is indicated as one, right? And then the second category that you have, we have prayers from maybe a Spanish league. Let's say maybe we have a two. So we can indicate that one. We can change that one to maybe let's say a Spanish league. I don't know the Spanish. I don't know any league in Spain. So let's say maybe we are changing this category to Spanish league, and then have the third the third category now. We are changing it from three to uh, let's say maybe we can have. This is now France League. So working with the names of categories will be easier, right? So compared to working with one, two, 1, 2, 3. So that is now a use case where you are supposed to change or replace those categories with their name. I think that one could be easier working with. So any question up to that point? Do you have any question? Okay, thumbs up if you are together. Yeah. If, I can see most of us we are okay. So you should try using a different data set, maybe one that needs you to customize the values. But that is it with the replace function. That is it with the replace function. But the purpose of this was to change all the null values to unavailable. And I think we have achieved that. So after that, we have also the function here. You can use the one Radovan was talking about. That is now the fill in. You can also use the fill in function to replace the null values with some values. So these are some of the functions that you are going to carry out. Here. Maybe the other thing that I thought maybe you could check in this case is how you can maybe checking duplicates. But with this data set, I didn't find any duplicate. I checked if you had a question. That is Rodovan Mosembi. Yeah. Is it a question, Rodovan?
Yeah, yeah.
Yeah.
Okay, can you, is it possible like to filter, like let's say for the players,
Yes.
like let's say for the average score, can you filter like those who have above 90 and all that? Is it possible?
That one is possible. That one is possible. In fact, you can also check the league names, checking the players in the number of players in different leagues, like the total number of players in a certain league. Maybe let's say EPL. We have the Spain the is it called the Primera Division. Those are things that you can achieve. But yeah, you can do that. You can achieve that. Um, maybe something else that we can check here. Um, let's see this. I don't think we have cases of duplicates in this data set. I think I had checked that. Just a minute. Let's just try and counter check these. Okay, which function did you use for checking the duplicates? Maybe someone can remind us. Which function did you use for checking duplicates? Who can remind us? I think someone can just type, and I can see this autocomplete sometimes shows you the answer. Who can help us to check the duplicate? I think this is something that I covered. Someone to help us to check the duplicates, to check if there is duplicate in this data set. Okay, yeah, we have relevance in the DF. Then we check the duplicated. Yeah, I think that is it. I think you can also see that from the autocomplete here, df dot duplicated. Then we can find the sum in each case. So if we run these, we are supposed to get, let me see this. If we run this, we are supposed to get if we have duplicated values, and you can see that we are getting an output of 0. So in this case, we don't have a duplicate issues, but they normally occurs. Maybe let's say in areas where maybe the person who was collecting the data having a multiple entry, having maybe a multiple what, maybe key a certain data, maybe more than once. But there is a data set that I sent you in the group. I think we're just going to go through. We're just going to go through it very fast. Because that data set, I think it has some duplicated values, so we are going to see that. So those are some of the functions that are that goes in this step. So if you guys now allow me, I think you can just move to the next step. And by there you can also check the value. There is a very useful function also in this step that is called the value underscore count. So this one will also now group Like you can see in this case, we are trying to group all the, we are just trying to group our data set, that is using the league name column, and we have the count for each league name. You can see that all the players, the number of players in Argentina Primera Division, it is 628. You can also check the English League Championship. We have 542 players, 542, 542 players in that league. These are some of the functions that will help you to even understand more about the data set that you are dealing with. So you can also try to use this one in your data set. So let's move to features understanding. This is now the step 3. In this step 3, we are going to do some visualization. I think Radovan had asked where we are going to use the, that is the, is it SNS, the Seaborn. But they imported some stuffs here that we are going to use. And you notice that I'm importing matplotlib.pylab as PLT. I think initially you are using the pyplot, not the pylab, right? But in this case, I want to use the pylab because I want to uh, I want to use some stuffs in this pylab that are not in pyplot. And you can see with that I'm able to let me just uncomment out these. So pandas by itself, it has you can use pandas by itself to do some plots. But again, we have options. You can use the matplotlib pylab to use options such as the GG plot. I think these ones they are quite. You have, in fact, when you use the ggplot, you have a variety of attributes that you can use during the visualization. So that is why I'm using the pylab as that is matplotlib.pylab as PLT, and I want to specifically use this option of ggplot. So maybe even before we get to the before we get even to the third step, there is something else that I would like maybe to share with you that also can really help you to understand the data set you are dealing with here. And this is the number, the maximum number of columns that are shown. Maybe before we use these, if we try to, let me show you this. In fact, it is visible here. You notice that when I use the df.head and then I pass 5 here, I'm going to get this output, right? But you notice if we check the shape of these, let me show you this. This is df.shape. We say that this will give us the number of rows and columns we have in a data set. And you can see we have a number of, we have 19,239 rows of data, and we have 110 columns, right? But if I use now the head function, what I'm able to see is just a few column names. And then you can see that at some point you are getting some dots, right? So if you want maybe to maximize the number of columns that you want to see, we have in PLT, that is matplotlib pylab, we have something we have option that we call the plt.set option that will enable you to increase the number of the number of what? The number of columns that you can show when you use the head function, or when you use the head function. So in this case, you notice that we are using this is the display dot max columns, and then you can just pass a number here. Let's say maybe you want to see like the first 60, the maximum number of columns that you want to see when we use these uh, df.head is maybe 60, or maybe even you can use the 110. Let's see if you're able to display all the columns. So let me just run these, and I can see we have a problem here. You're going to check that. So let's see if you're able to use the set options function. You can just try and use these. Just try and use these in your case, because I just realized that I don't know if it's because of internet or what is not happening. This one is very slow in how it execute. I'm told that the PLT doesn't have use. We just try to. In fact, it's supposed to be styles. That is styles dot use the ggplot. So let's run that again. I can see I have a problem. I can see I have a problem here. Let's see what the error is. In fact, these are some of the things that will help you to understand your data set more. Let's see this. I think it should be set options. Let's see this. Set underscore. And there should be options. Or is print options. Let's see this. So let's say this, set this one to 110. But I think this is something we can check. We can check later, because I think it's taking much time to execute. I can see we have a problem here. Well, it should be options. I'll check this later. Let me just comment it out. So let's get to the third step. I think I'll share with you the line of code that will work. So let's get to feature understanding. And with feature understanding, we can only understand features using some graphs. And in this case, I just want us to use the graphs that I showed you how to draw. Maybe you can use the graphs such as histogram. We have other graphs such as what you call the KDE. We have box plot. You name them. I think we studied several graphs. So in this case, I would like us to pay attention to this column. That is the overall. We can have the overall potential of a player, and also we can check the potential what. You can also check the potential column. I think you can also check. Maybe you can check the wage in euros, and also maybe the value of a certain player. I would like us just to pay attention to these four columns here, and I would like us just to carry out just a univariate analysis here, and maybe we can check. Let's check what can we check? Uh, let me see this. Let's check the players with the potential of the players with the potential of knight one. That one is something that we can definitely get. We can also check the players with overall the overall potential of knight two, knight three, because I can see their number. So let's see how we can start by that. And it's quite easy because now I already introduced you to the value count. In fact, it is very easy because we're just going to use the df here, and then we just have to specify the column. In this case, we just want to use the overall. This is the overall column. Then the overall column, use the dot. This is the dot value. We can check the dot value count. Let's see this. If we just try, in fact, this one is a function. If we just try to run these, let's see what we have. Let's see this. And you can see we have the overall and the number of players with that overall count. Like the players with the overall of 65. We can see that they are 1,251, right? We can also see that there are players with the overall of 64. They are about that is 1,188. So this one is in ascending order. So let's see the players with that is the overall value of 93. You can see we have just one player here, and also you can see the players with 92. We just have one players. But now moving on from 90, going downwards, at least we have a number of players sharing the same overall value, right? You can also check maybe this is the overall count. Let's just show that. Count in each overall. We can also check the potential. Let's use this. here. We can also use the potential column, potential. This is df, then potential. I think you can just comment out this so that we see the counts in potential. Should it be potential? I think it should be potential, and we can see also we can see how the potential is also distributed in our data set. We can see all the players with a potential value of 72. They are 1,315. Again, just going downwards, we realize that we have players with the players with potential of 95 is just one. The 90 they are a number. This is just the kind of information you are able to derive using some of these functions. Just understanding the features how they are distributed within your data set. Maybe even we can try and we can just try and maybe visualize these using some graph here. Let's see. I think we can just draw a bar graph to display these. Starting with the overall. Let's just try to use. I think bar graph will be okay. Use bar graph to visualize. Should be to visualize. This is overall distribution. This one is just quite easy. We can have a visual of the bar graph, and how we draw that is very easy. We can have df. We can have the df dot. Can have df. Let's have these as overall. It's just very easy. We can have the df and then overall and then dot value count, and then we want to plot this kind of a visual. That is the bar graph. With just this one line, you're able to do that. So let me just comment out these and run these to see if we're able to see these plots. So again, you can see that now we have at least now we can visualize these, and we can see the players with 67. Is it no 65? Having the highest what? This is the overall, and then we have the count. We can see that the overall, that is 65, has the largest count of about, I think this is around maybe 1300 and something up to this point here. If maybe you're able to enlarge these, let's use this. Use large figure size. we're able to, we can just try to use, let's see if we're able to enlarge this figure size. We can increase the value here to some value, maybe 20. Let's use that to 20. Good. I think with this we're able to see how the overall is distributed now, because at least now we use a larger figure. In fact, this is how we use a larger figure. Let me just show you that. You can enlarge this figure by using the plt.figure function, and then you just pass. In this, you just pass the figure size. That is the length and the width of your figure. And now you can see how they are distributed, right? You can also just try to do the same with the potential. You can just have, let's copy these and paste it just below this, and use now the potential. So do we have any question as we wait for the plot to appear? Any question? I think we have the plots now. Let's see this. We have the potential plot. You can see again, that is 72. We have a count of again about 1,000, maybe 300 and something, is the value that is having the highest count. So any question regarding this? Okay, thumbs up if you are together. Yeah, you can simply also change this one to, let me just try to change this one to, should we use, let's just try to do a KDE. It's called a KDE what? Not KDE number plate, but a KDE graph. Huh? So let's just try to have a KDE graph here. I think you should be able to see the KDE graph. You can also see this distribution here in the KDE graph. This is what we call the KDE graph. You can see also the highest value here, and it seems there are cases where we have negative values. But this is not the best graph to use. Let's just stick to bar graph in this case. So something else that we said is that when you are drawing these graphs, make sure that you label your graph, right? So, and how we do that is it's quite easy. Just labeling these. It's very easy. In fact, you can just save this maybe to, let's say, axis. Axis is equals to this. Then even here you can just add a title. Let's have a title here. Is equals to, that is the overall distribution. When we set this one to x-axis here, that is the axis. We can also simply set the that is the we set the x label, and also we can set the y label. So if now I run this, you can see that now my graph is my graph is labeled. So there is someone who was asking how we can save these. So I can just show you the best way. Instead of writing code to save this, I think you can use the snip. I know you guys, do you know how to use the snip? There is a snip tool. We have a snip tool in your machine for those of us who are using Windows. The snipping tool. I think this is the best tool you can ever use to maybe to let's say maybe I want to use the snip to take these graph. Yeah, I always use this snip. I find it I find it very easy to pick these graphs, and now you can see that I with just that I'm able to take that pick. I think if I'm not wrong, it was a Pondi. Harriet, is Harriet in? I think Harriet is the one who. Yes, Harriet, how are you? I think Harriet is the one who was asking about how you can how
I'm
you
doing
can.
well. Yeah, I'm
Yes,
the one who asked.
yes, Iveka, yeah. So you can simply use the snip tool, the snipping tool, instead of writing code to save just each and every graph. I think you can always use the snip tool to take those graphs. So I think that is it. I think by now you have a rough idea of what happens when you are told to do analysis on a certain data. It is a series of many steps, so that now you can at least you cannot analyze something that you cannot analyze the data that you are not you do you cannot analyze a data set that you have no knowledge about. So that is why we have now this EDA process, just taking you through that data set, so that at least now you're able even to answer the business questions comfortably. Um, I think that is all about feature understanding. In this step, you can either choose to go maybe row by column by column, depending on. Of course, we have what we call the guided analysis, right? So meaning that you are given a certain business questions. So those business questions, they are going to guide you on the columns that you should pay attention to, right? So though feature understanding will highly depend on the business questions that you are to solve at the end of the analysis. So in this case, I was just doing an overview of these two. In fact, these two columns. That is the potential and the overall um, values of a player. So I think that is it with that step. I think I don't have much unless there is any question regarding that. Any question? Any question on that? Okay, I think Rodovan who had asked, you had asked where you use the SNS, right? Was it you, Rodovan? Yeah.
Yes.
So this one is just these are default. I call them the default plot that comes with pandas. But now you have options of using SNS. So how you use the SNS? Let me just show you. I think I can just let's just try to draw this. Um, I don't know which column I can use here. Let's just have a simple scatter plot. Let's have a simple scatter plot for which column should I use? Let me just use the edge. Let's say maybe you want to use the scatter. You want just to see the scatter. Use the scatter plot to display the edge here. It's very easy how you use uh, the seaborn. You just have like to invoke that seaborn SNS. We import it as a CNS, and then we can just have. You can see we have many options that we can use. We have. Let's just focus on the scatter plot. The scatter. That is a scatter plot. And then you can see what we pass. If I was maybe to put my cursor here, I'm able to see the data that we should pass here. The first thing is your data frame. You can pass things we call hue. You can also pass the styles. So in this case, we can just maybe pass let's have let's have the data as DF, and then in this DF we would just want to focus on a certain column here. Let's say maybe age, and then we can on the y-axis we can have the overall and then the potential. So I think that one is you can just have that. Outside I can see we have a problem here already. Data source must be data frame or mapping. Let's see these. Let's have let's say data is equals to df that is overall. Just for to print data. So you're able to see the overall. In fact, in this case, we can just pass the whole data set. That is the df. And then from the df, we are able to choose that is on the x-axis, we just don't need the overall column, and the y, we just need the potential. I think that is where we were getting that error. So let's just try to do that. So, and I think you're able to see how you can use the CNS, right? Rodovan, you can see how edges are distributed here. Just that easy. Just have like to pass your the data set, and then specify the number of that is what should appear on the x-axis and what should appear on your y-axis. Also, SNS we have something that we call peer plot, and that this one is very useful, especially in times in places where you want to compare a number of let's say columns. I think you can just try to do that very fast. So we have SNS dot pair. It's called pair plot, right? Yeah, it's called pair plot. And then in the pair plot, we just have like to pass now the data. The data here we are setting it to our DF. And then you can pass now. Let me just leave the hue first. What we need is something called the variables that we want to compare. Let's say maybe in this case we want to compare. We want to compare what should be a list. Let's say we want to compare the overall and potential, or let's do. I think you can do age and potential, right? So that we can see if age affects the potential or the age is affecting. I think you can just start with the overall. This is the overall. We check if maybe the age, uh, you can just do the, let's start with the potential. Let's see if the potential, if the age of a player affect his potential. And now in this case, you realize that we have started doing the multivariate analysis, because now we're just trying to compare two columns, right? Two columns of data here. Just checking that if age affects the potential of a player. So let me just comment out that, and let's see what we have here. So we have the potential and the age here. So you can see we have a number of plots here. That is on the age. We have like the age here. Let's see these. Uh, with this data set, you are able to see that the players within this age, that is the age of most of the players where they are productive is between the age of 20. I think you can see so many values that is in between 20 and 40. But you realize when now you are at this age of maybe 40 and above, you are not you don't have you don't have a large potential, right? And that is why we can see above 50. We just have one. We just have one dot here, just to mean we have. Is it one player? We have one player, and you can see also that the potential is not that great. So with this you're able to compare, that is the potential and the age. You can also just try to check the overall. This is the overall. Let's see the overall here. Let's just try to add something we call hue. We can group this by, let me see this. Let's have this by league. Was it league name? It should be league name. I think it should be. Let me copy this. The league name. Just a minute. Let me just counter check that. It should be league underscore name. Yeah, I think we have it. I can see we have an error again. Should be league. I think we have a typo somewhere. Yeah, it should be league name. So you can see now with just adding hue, with just adding hue, you are able to we are able to we are able also to check how these players, in as much you are checking the relationship between the age and the overall value of a player. um, we can set up a hue, so that now we can group, we can see how players play in different leagues. And that is why now we have these, like the and this one is going to be indicated by these colors. Like for the French League One, we are going to use the red. So anyway, you just note we have a red. Is this red or pink? I'm not good in colors, by the way. So you can see anywhere you see a red dot, you just realize that those are players from French League One. So the reason why we use SNS is because we have a number of options that we can use to make our graphs more, uh, maybe look appealing, and also display a lot of information. Like with this one, with just this single pair plot, you're able to learn a lot of things just using just using just that. In fact, you can just see we're using just one line of code here to display the league name, and also to compare between the age, how age affect the overall value of a player. Just with just one, just using the single line in Python. So what I would maybe request you is just I'll share a link for the Seaborn, that is the Seaborn documentation, so that at least you can see the number of options that you can use during visualization. And also you can, as well as now, copy these again. Harriet, you can also use the snipping tool to take this graph and incorporate it in your report. So any question up to that point? Okay, thumbs up if you are together. Yeah, I can see Kiziri, good. Mombi, good. So I think now you can see the essence of having the essence of going through the EDA process. I think you have learned a lot. If you can confirm that. Uh, yes, I think that is it with this part, by the way. So maybe something else maybe that I would like to check here is something that we call the correlation. Um, Maybe with the correlation we can use the next 2 or 3 minutes too. to check this. Then we can call it a day. During understanding of your data set, you might want to understand how different columns are related to each other. That is especially now the numerical columns. So with that we have something that we call the correlation. We can check the correlation using the correlation matrix. And then after that, you can have again a visual representation of that using the heat, something we call the heat map. Let's see how we can do that. The correlation matrix. With this one is just a single line of code. So whereby we are going to have df, and then we can do what? Maybe we can let us just try with the correlation matrix. We compare columns with what we call the numerical values. You cannot have a correlation matrix on columns that have maybe strings. The correlation must be the correlation columns must be in numerics. So let us just check how again overall and the overall. I think we can have age and the potential. Let's see how age and what. I think you can check the overall potential. And I think this time we can just try to use a different column here. Let's see how the overall value of a player affect the wage. I think that one would be that one would make sense. So let's have this column. That is the wage underscore. That is EUR. I think that one is to mean euro. Wage euro. So let's check that very fast. So we can have the overall, and then we have the wage. The wage is in euro. So before you check the correlation here, I would like us to drop all the null values in this case. The drop, we use the drop now. Oops. We can drop all the null values. Then we have another function that will help us now check the correlation. We call it the call function. This is now the correlation function. So with this, we are able to get the correlation matrix. If we run these, oops, we have an error here. Let's see the error. If we have a list like chicken index, let's see this. Yes, I think we have an error because we are trying to do an illegal thing here. We must use for the DF we use the first square bracket, and now for the second square bracket we pass a list of values. So Let us just wait for it. And you can see we have a correlation matrix here. Maybe let's even add the potential here. We can have potential. And also even we can have age. You notice now that we are checking the correlation between like 4 columns of data. So let's see this. And this is now the matrix where we see that the correlation between overall and overall, you notice that is 1. The highest value is always 1. So the correlation between an overall value and overall value is 1. The correlation between the overall and the wage, that is the payment, is it's about that is 60%. The potential, you can see the wage and the potential. I think we have the overall the overall value of a prayer, how it correlates with the potential. It's it's marked at 64%. We can see the overall potential of a prayer. How it is affected by age is by 45%, or what we are just calling 0.45. That is in decimal. You can see we can see that at some areas where the correlation between the potential and the age, we can see it's a negative value here. That is negative 0.26. So this is now the correlation matrix. We call it the correlation matrix. And this one you can do you can represent this in heat map. So let's see how you can represent this one in heat map. Just 1 minute, and then we leave at this point. Let's see how you can have a heat map. This one is now the graph representation of the correlation matrix. We call it the heat map. So this is the heat map. This is the heat map. So it's very easy how we do that. We just have now to use the I think you can just maybe assign this one to something like what the correlation, the call underscore matrix. Let me use this very fast. Is equals to that. And then now we can use the call matrix in the heat map. So you're just going to use the SNS dot heat map, and then what we pass in the heat map function is just the correlation matrix. And let me just try to remove this R naught parameter and see what happens. What is happening? The call matrix is not defined because we didn't run this again. So let's do that. So let's see our correlation at the heat map. That is the visual representation of correlation matrix. Very fast. Yes, you can see now the representation of correlation matrix in a graph format or in a plot format. So it's just me. It's just the same. You can see that we have where we have. I, I don't know. I don't know these. I don't know these colors. I don't know whether this one is. Okay, which color is this one? I think someone can just tell us. Which color is this one? I think ladies are quite good with colors. Which color is this one? Okay, someone can just tell us. Mombi, which color is this one? And you can see it forms the diagonal part of matrix map of heat map here. Which color is this? If someone can just admit and tell us. No one? Harriet, which color is this one? I think you can help us with this color. What is the name of this color?
Maybe it's blush orange. I'm not sure.
Okay. You called it brush orange, right?
Yeah.
Yes, maybe we can. Okay, let's use that one because even I don't know what the brush orange is. So yes, let's just call it orange, and you can see it forms uh, the diagonal part of a map, right? So meaning that the correlation between a column and itself is always one, and you can see this one in you can see that one in these in this bar here where we have the brush orange having a value of 1. You can see, of course, you can see that one now goes reducing up to where we have a value of negative 0.2. So meaning that we have cases where the correlation between columns it's negative correlation. So I think that is it with the heat map representation. I think there is something that I removed here. Let's see what the anode does. So the annotation will just add the values. That is the values of correlation. And you can see that in our graph here. So instead of using now this bar here to figure out the value of the correlation, you can just use the anode attribute. We set it to true so that those numbers can appear in your graph. So any question up to that point? Okay, thumbs up if you think you have learned so much today. I can see, yeah. I think that is the essence of having reliable internet. Yesterday, you were a bit, we faced challenges with the internet. But basically, that's all about the four steps in the EDA. Maybe tomorrow, because tomorrow I intend to I'll introduce machine learning. I'll introduce some machine learning. We must learn some machine learning models, and we see how they work with different data sets. So I think we have checked the step number 4, the relationship between the relation that is uh, the relationship of columns in the data set, and then the remaining part. This one is now highly dependent on. This is highly dependent on what you are asked to analyze, right? So, because now, let's say maybe you are checking the data on sales. Uh, the person who is asking you to do the analysis, there is something, or there are a number of things that he want to understand about the sales data. So he or she will provide you with the question that you are supposed to answer. But again, I'm going to take you through. I'm going to take you through. I'll take you through some of the questions that are asked during in different data sets. That maybe we can check the HR data set. The HR data set. You see the question that they normally ask. We check the finance data set. Some of the questions that they normally ask. Um, when it comes to do what to which other data set? I think we have finance, we have sale. You check the HR data sets. Those are some of the data sets that you are provided with, so that at least you can derive some meaning from those data sets. So you guys have a good night. Let's meet tomorrow at the same time. Is there any question? I can see Harriet Apondi has a question.
Yeah, I wanted to ask around how many lessons are we left with?
You are supposed to have, I think there, I think we have, we're supposed to have a makeup class. That is one. Then there's supposed to be 6.
Okay.
Yeah, we are supposed to have extra. It's actually extra 6. We have extra 6 to go. So any question? That is now the makeup class included. Any other question? So if no question, you guys have a good night. Let's meet tomorrow.